Okay, so here is my overall level for my Game Scripting for Designers class. So what I ended up going for was a basic level design with a few puzzles, and mostly it's based and built around the mechanics that we ended up putting into the level. So that's what I'm going to get into a little bit more depth about everything that's going on here. But the main thing I wanted to stress about this was actually getting in depth, learning a lot of the more advanced systems, and seeing what we could actually come up with and do with some of the more advanced things and just explore what the engine actually ends up doing. So first we're going to give a little bit of playtest, and then we'll talk about the blueprints, and I'll talk about everything as I go along. So first off, we start off here, and as you can see, we have a health bar, and we had a bunch of text that was talking about saving our game and all this other stuff. So first things first, our prompts to see what our controls are and what some of our inventory and stuff are. So if we press 1, we see we have a 0 there, which is our number of keys. Now, over here, press E to interact with box, which is talking about this. And as we can see, it is fairly dark. It's light enough, but we can end up seeing some stuff through there. So the main thing here, so the main thing here is that it's still quite hard to see. So let's try to brighten it up. So if we go over here and we press E, that turns on our light array, which ends up brightening everything up and also activates our particle array, which we have quite a few around the level. Here's our second checkpoint. As you can see, it says our X, Y, and Z coordinates, and we get a little bit of a prompt about certain things being interactable. Now, if we see, we have a few particles, a few different types of particles, and some stuff that seems to be going on. Now over here, this says door automatically opens if we have a key. We don't have a key, so we need to find something to be able to open it. So if we come over here, we'll notice we have a prompt for an elevator that does not work as is. So we need to get something to put on this little platform, which comes into our manipulating an object mechanic, which is picking up this box, carrying it over here as this is our air quotes battery, placing this into the level. We get our prompt that power seems to be on, and then we press E and we ascend. So that is our little lock and key for the elevator, and then we have step near items to automatically pick them up. That was our key placeholder, along with a little bit of atmosphere for our light. Press E again, and we slowly go back down. Now, if we go over to our door now, and we have our key, it should open. There we are. And now over here, we see that we have a little area that's showing us what's going on in the next room. So we can kind of make out these two little guys right here and right here. So we're going to have to stealth around them somehow. So this is take control of other people by pressing E in our machine, which is this. So if we press E, we now teleport to this other player character. And we have our AIs here and our little rotating camera. But if we seem to get close to the AI, it automatically runs towards us. We haven't put any functionality for it to kill us yet, but it generally doesn't like us, so it makes performing a level fairly annoying. And after a while of patrolling and not seeing us, it will then run back to its initial spot. Next, we have our pain volume, which we have our particles here so that we can tell that something is amiss in this area, and it is slowly draining our health. But once we get to the end, we have completed our level. So that's the main walkthrough of everything that's going on in the level. And now let's get to some of the interesting stuff that goes behind what we're doing in this level exactly. So if we go over to our blueprints, we have quite a few. Some of the easier ones, like this, was our flickering light that we had. It's just a random light generation for our intensity, and we put a delay, and it makes a random duration and intensity as it goes. So that's that. Next, we have our key system, which is a little easy depending on what you're doing, because if we go and look over here, all we did was make a little inventory that says when we press 1, we print a string, which is our integer, which is our number of keys that we have. And then key, which is our object, which is we go to pick it up, we get into it, it then adds 1 to our number of keys that we have, and then destroys the actor. And then our door is what checks for that. So we say, hey, when we overlap close enough to the door, we look for greater than or equal to amount of keys, and then subtract that number from our inventory, and then we play our timeline for our location lerp to set our relative location. So that's pretty easy. Then our sign prompts, we just have a basic, hey, this generates to the HUD, because if you do print text strings, that actually doesn't show up on the actual game. So we wanted a way so that we can actually prompt people in our game in a final build. So this was something I found out about and was that this is more worth learning than some of the other things that we have going on. Our win text is basically the same thing, but we took that principle and just made it a trigger box instead of a trigger box with a mesh and object inside of it. Then we have our power on variable, which is just basically casting to our trigger battery, and when this is in, it allows us to then play our location and set power on, which is basically our boolean of if the elevator can go up or down, because it needs that as our condition. That's basically it for that. And then we have our light toggle, which we have two. It's just, hey, this starts off closed, and when we're in E and we get close enough, it sets our toggle light on for our arrays that we have made in our actual blueprint for the model. And then we get into some of the more complex stuff that I felt was worth more than polishing the level to look spectacular. And this is something that I felt really added to the intricacy of the level without really diminishing much. So first off, we have our pickup object and set grab location and all of this over here, which is basically us getting a vector from our main character when we right click on to trace for objects from our custom pickup event, and then we're looking for a break hit result on a physics object to then pick it up, and then we change what it is into a pawn and change its dampening so that first off it doesn't just fly off as soon as we let go for us actually throwing it, and also we don't collide with it and stop ourselves from moving with the object in hand. Then we have every event tick. We're looking for our set target location for that. Whenever we use that, then we have our right mouse button, which is our action to drop and pick up, and that ends up going to our physics handle for what we're doing with that object. So that is basically where we are with that. We also have quite a few things over here, but I gotta get over to some of the other stuff to explain what's going on here. So first off, our health bar, which was a GUI element of just having this progress bar with health on here, so that wasn't much. the thing that makes it interesting is when we go back over here and we look at whenever we're taking any damage, we take our health value and our max health value, and we subtract A and B of our variables, which we have over here, which are our float values. And this gives us our percentage health of decreasing health that we can end up setting from our max at 100 and our current health at 100. And then if it is ever below or equal to 0, the actor is just destroyed. And that's basically how we set that. And then for our UI health bar, we just created a game mode widget that added it to the viewport. That was basically it. There was nothing much more to that. It was pretty simple. The next mechanic that I added in was a checkpoint system. Now this was a little bit more trickery because this had quite a few things that we ended up having to do to get it to work. So first off, we had to set up a separate thing besides all of this in checkpoint, which just saved certain information, which we're looking for basically location here. That's basically all we're looking for, and that's all we're casting to in this blueprint to talk about, which is our checkpoint location save file and our checkpoint save. Alright, so first up, when we overlap with the box, yada yada yada, we get and set our location right then and there. So that's what we're putting in. And we're going to check to see if a save game exists. If it does or doesn't, we're going to end up doing basically the same thing. If we don't have it, we're going to create a save game object, which then goes into our saver subclass and cast to save checkpoint. And we get our last location, and we get our location and set it to whatever it is. And then we save to game slot, checkpoint location, and then we print out that the game's saved. And then whenever we do already have one, we're then just going to save over that with load game from slot. Now we need both of these, and we just can't have one, because when we go over here, we end up having to load from slot quite often. So we did event begin play, and we used a sequencer to get this all to work for our save place checkpoint, because this is also vital for figuring out where we actually are and putting us to that space, because otherwise we have information and nothing to do with it. So we print a string of started so that we can see the development is working. Then we get the checkpoint location, save a subclass, and we cast that and get our target location and set that to a teleport. That's basically it. Now we got to do this quick enough, and we got to make sure we don't set our checkpoints over where our initial spawn point is on the map, because if we do that, we'll spawn there and then just end up spawning at the start of the game instead of to our new save location. Even though it happens in a split second and you can't actually tell what's going on, it will mess it up if you don't do it that way. Now onto our respawn for this, we end up just putting an event destroy open level, and then we can specify if it's the current level, if it's a different level, basically anything that we need. So that's not too bad. Then our next point, and this is the biggest thing that I ended up spending most of my resource time to for this whole level, was my AI. Now my AI doesn't patrol yet, and that was something that I wanted to figure out and get working, but I just couldn't. But overall, what we ended up doing, we ended up going a route that more professionals end up using in the industry besides just a blueprint. We ended up using a behavior tree. Now this ends up giving us a lot more flexibility, and we can make if or and statements, and then going down a huge logic map with what we have. We just have a basic one here, which is basically our root, which goes to our selector for our aggro check, which I'll get into what all these code things do, but basically it goes and gets target to follow and the target location, and it checks every 0.50 of a second. Then we go to, if we do find something, we go to the Blackboard base condition, target to follow is set, and close enough. which is basically the acceptable distance right here that the target will follow in, and then it will use a rapid move to move towards that location as long as it sees it within its condition. If it doesn't, it aborts everything, and then it goes over to its then statement, which is our Blackboard-based control target to follow is not set, and then we look is at location home local, and this is inversed so we know where our home location is from where we now are. Then we're going to target local is set, and then we're going to put a sequence to move to target location, then wait 2.5 seconds at that location to see if we see the player again, and then move back to home local, which is the starting position that we have dropped the AI into. Now, overall, this goes through quite a few different things here to make this actually work. So going through this, we end up looking at quite a few things, and we only really need most of all of this stuff to just say, hey, look at these specific modifiable things that we need to make this work in our actual code. So when we go through aggro check, basically this whole thing is saying, hey, cast to the AI brain and make the AI brain look for the actor in his multi-sphere trace for objects. And we're going to use it as an array, and if he gets a hit on a target actor location, then we're going to have him trace to that and get my location. This is going to set for his home local. Then we go to break target, and we're going to say if A and B are equal, then we move to the next thing, which is our branch condition of setting our Blackboard target to follow if it is or isn't there. And then also we need to get our target location. So basically this whole thing basically says, hey, I need you to look for a specific thing in your sphere of influence, which is his vision. Then I need you to get your location of where you started, where his location is, and what to do with that location to follow to. That's basically all AgroCheck does. Then we go to rapid move to. So this is basically saying, hey, we need target to follow, and we're going to tell the AI brain that if he sees the conditional pawn, then he's going to move towards it and finish the executable, which ends up going into transitioning to the next thing, air quotes, in our blueprint, which is our AI tree over here. Then the last thing we have is we're going to perform our condition check for the AI brain, and then we're going to send that into a return node. And this is basically saying what our acceptable distance is to follow, and also, hey, if you don't see it, what are you doing? That's basically all this ends up doing. So once we have all of that together and we just plug it in as so, with the if-and statements and looking for our key queries, it basically makes a super modular AI that we can end up adding different versions of each of these aggro checks, depending on if we have a standard grunt, basically a weaker version of a grunt, and then an elite enemy, and then special enemies for bosses, and how they react to certain situations and what they do. And then we can end up using the same stuff for all of these for multiple Blackboard behavior trees, which then means we're using less resources, less time for coding, and having a higher turnaround on our characters. So that was the biggest thing that I ended up adding in. And now if we go and check on the AI, because that's something I didn't really do, if we go over here and we look at what it really does, see, we got close enough, and now we're in its acceptable distance of saying, hey, you're close enough to me to do this thing, and I need you to work within a specific area. And he's going to just keep following me until we break line of sight. And look, right there, he waited his 2.5 seconds and saw us again within that time. So then he resumed chasing after us. So this is a great way to not have any AI path nodes and still get what you need to work. So this was a really interesting way of making this style work, and we can even get multiple people stuck on us at a time and get the AI to work generally the same, which is pretty cool because then we can have more responsive AI, and then we can start setting values to certain areas that they walk through with post-processing volumes and other types of volumes so that they end up wanting to go through certain areas more or less. So that's my level. This is all of the integration between all of the projects that we've ended up doing overall, and me exploring into what is some of the cooler things I can end up doing, and some of the more industry professional standards that I need to start meeting with my projects instead of just looking for the bare base bones. How can I mock up a level and actually start running on developing a game?